We're going to start at least our conversation about rational functions. We've been doing a unit here on polynomial functions so far, and we want to include rational functions as well in this unit, among other things. And I think you'll see why these ideas connect very, very nicely. I'm already like kind of yielding to the bell here. I realized we're only going to get, I thought, well, maybe we can get through 2 slides, and then we'll just continue on Tuesday. The homework for tonight is not from this stuff. It'll just be to finish the challenge problems, okay? So, but we can start talking about rational functions. Here we go. All right, so what is a rational function? Does anyone know out there? What do we mean by rational? Is that a hand, Jasper? What's a rational function? Is that a hand? Go ahead, let's make sure everyone's listening too. What's that? As a fraction? Is that what he said? You didn't hear Jasper, but he said a function that can be expressed as a fraction, which is mostly what we want to say. Yeah. The only caveat that we will make, and this is just because this is the definition we're going to give, is that these two functions be polynomials. Okay. So this is why this will connect a little bit to the stuff we've been doing. If you take a polynomial and divide by another polynomial, you'll have something called a rational function. So I know you studied a little bit about rational functions before, which I'm going to assume that you know something already as we move forward, and we're going to try and take you deeper than you've been before, as usual. Rational is a good name for them, right? I mean, rational makes me think of like rational numbers, which you understand as being like a ratio of two integers, yes? So that makes sense. It also makes sense in light of the fact that as we've studied polynomials recently, we've started to realize, as we did long division, as we talked about the fundamental theorem of algebra, etc., we realized that polynomials feel a lot like integers, don't they? Like the way they behave. Well, if polynomials are analogous to integers, then it would make very good sense that rational functions be analogous to rational numbers, right? Because the rational numbers are integer divided by integer. So I think you'll find that like lots of the things we've said about polynomials and integers are going to be true about rational functions too. So yeah, you'll see even on this slide some connections between some of the ideas we've already had in this unit and what we're doing now. Take for a second here with your table and answer I think you can answer all of them, maybe, I don't know. This is a unit 1 question, actually, okay? So this is a function from our 1 over x I have in my hand here, right? One of our friends that we met last unit, one of our basic functions. And I think I could have asked you this even on the last unit's quiz or test or something, right? Tell me what these are in terms of transformations of this function. Give me like instructions on how to graph it. So with your table, go through and see if you can just recall what transformations these are asking for.
See, whatever you do for what's happening to the it's reflecting over the x-axis. And then you want to go after the reflected. And then the next what is CC's 2 of x? Wait. Would be and then vertical transformation. The first one you would shift the left 3. That's pretty much multiplying it by 2.
I know it's chaos.
Right there.
All right. All right. Start us off where over there. On A. Say it again. Left 1 unit. Okay. And that's it. Just left 1 unit. Left 1 unit. Is that it? Does that look good? Is that what you guys said? So I just do this. Boop. That's how it looks. You disagree, Cassie? Okay. Yeah, I think I want to think about what negative x looks like, negative 1 over x looks like first. So yeah, I think that's like negative f of x. This is of the form negative f of x plus 1. So I think we understand that to mean a reflection over the x-axis and up 1, right? Okay. What about B? Piper, how'd you do on B? What did you say there? Yeah, is that the one you were answering at the sum, maybe? B? Maybe that's the one you were looking at. Okay, all right. So this one is left 1. I think I agree. And that's it, right? There's nothing else to say there. Deeksha, how did you do on C? Where is she? How'd you do on C? Okay. So, yeah, vertical stretch or dilation by a factor of 2. Okay, I think I agree with those two. And then what about this last one? Is this, you might even have a question, is this a transformation of this guy? Maybe it's not, I don't know. Each function is, it says. So that's a lie? Is that what that is? Let me ask you this. What does this say, actually? It says 3x minus 7 divided by x minus 2. So let me just show you something if you haven't seen this before. I mean, this is what that literally means, doesn't it? Right? Aren't you doing the top divided by the bottom? So what do you get? Well, x into 3x goes 3 times. Multiplying gives 3x minus 6. Subtracting gives negative 1. So writing in fraction form, what is this thing divided by this thing? What's the answer? 3 plus remainder divided by divisor, right? So I think what we've just done is done a little rewrite on this, haven't we? That helps us see what the 3 transformations are, right? Is that cool? And certainly if you have linear over linear, if you have something linear divided by something linear, then it's definitely a transformation of 1 over x, isn't it? All right, so we won't write them out because the bell I think is supposed to ring like right now. I just looked in the agenda book. I don't know. Am I right?
Yeah, that's what I, yeah.
9:16?
Yeah, that's what it says.
All right, so, but I think now you can write out what the transformations are. We'll pick up there on Tuesday. We'll talk some more about rational thinking on Tuesday. Challenge problems for homework tonight, this weekend. See you on Tuesday. Have a good long weekend. All right.